Mount St. Helens sits on one of North America's most dangerous volcanic zones. Beneath its shattered slopes, a grinding subduction zone fuels the volcano that millions live beneath.
Mount St. Helens, a Washington state volcano, has been dormant for over a century, but today it erupted with smoke and ash after a week of earthquakes which rattled the area. The volcano oozed lava and belched an explosion that was heard up to 45 miles away.
Mount St. Helens, located in southwestern Washington state, about 50 miles northeast of Portland and rising from the spine of the Cascade Range, sits on one of the most dangerous volcanic frontiers in North America. Perched above the subduction zone, where the Wanda Fuca plate grinds beneath the North American plate, this shattered stratovolcano watches over dense forests, river valleys, and millions of people living downwind of its ash. 45 years ago, it blew apart with a lateral blast that rewrote US history. Today, satellites and sensors are once again picking up unsettling signals. Subtle quake swarms, strange ground changes, and ash from its old scar lofted high enough to trigger fresh alarms. The USGS insists there's no eruption in progress, but the data now hint at a deeper, more mysterious story beneath the Cascades. Is this just background rumbling from a restless volcano, or the first quiet move in Mount St. Helens' next catastrophic awakening? Chapter 1: Mount St. Helens Legacy. On a calm Sunday morning in May 1980, the world bore witness to the fury of Mount St. Helens. A powerful earthquake ruptured the mountainside, and in a blink, the once graceful peak transformed into a gaping wound on the earth. The volcanic cone, once rising to 9,677 feet, lost 1,300 feet of elevation as a massive debris avalanche, the largest landslide ever recorded on Earth, roared downslope at speeds exceeding 110 miles per hour. It swept relentlessly toward the Toutle River Valley, obliterating forests and reshaping the very contours of the land. In the wake of this collapse came a lateral blast, a sideways explosion driven by pent-up volcanic gas and superheated ash. This blast, hotter than 660 degrees Fahrenheit and moving at hundreds of miles per hour, leveled 230 square miles of pristine forest in seconds. Everything in its path was stripped, shattered, or incinerated. 57 people perished, and hundreds of homes, bridges, and miles of highway were erased or left in ruins. But the devastation did not end there. For 9 hours, Mount St. Helens ejected a colossal column of ash 80,000 feet into the sky, soaring into the stratosphere and riding the jet stream, plunging daylight into eerie darkness across the Pacific Northwest. Ash drifted as far as the Great Plains, silencing traffic in Spokane, closing airports, and contaminating rivers, lakes, and farmland for hundreds of miles. Volcanic mudflows, or lahars, surged down river valleys for days, burying communities and forever altering the region's waterways. The eruption left behind a smouldering crater nearly 2 miles wide and more than 1,300 feet deep. The landscape was unrecognizable, a wasteland of twisted trees and sterile grey. Yet, within this wound, life eventually returned. Today, the basin harbors Spirit Lake, reborn amid the destructive legacy of 1980. Why did Mount St. Helens erupt with such ferocity? What makes it uniquely volatile among Cascade volcanoes? Scientists sifted the evidence, layers of ash, pumice, and ancient lava flows, to piece together the hidden story. They found a legacy of repeated cataclysms stretching back millennia, each eruption reshaping not only the mountain, but every ecosystem, waterway, and community across its reach. Can history predict what lies ahead, and could we ever be prepared for what the volcano might do next? Are magma pockets shifting deeper underground? Is pressure redistributing along the volcanic arc? Could multiple volcanoes be responding to the same regional stress? Is this another incremental step toward renewal of activity? Recent monitoring shows subtle inflation at St. Helens crater floor, tiny increases in volcanic gases, and shallow seismic activity migrating along its south flank. Meanwhile, Mount Rainier, often called the most dangerous volcano in the continental United States, has recorded tremors within its ice-filled edifice, reminding scientists how vulnerable the mountain is to collapse-triggered lahars. None of this guarantees an eruption, but each shaking signal underlines a sobering truth. The Cascade Range is alive, and its volcanoes never truly sleep. Communities built along river valleys, highways, and forested slopes depend on what happens beneath these peaks. Emergency agencies track every tremor because the Cascades are capable of producing catastrophic ash plumes, pyroclastic flows, lava domes, and deadly mud flows that can reach populated areas in minutes. So what do these Mount St. Helens quakes really mean? Are they routine murmurs of a restless volcanic arc? Or early hints that the deep, molten machinery of the Cascades is shifting again in ways we cannot yet fully understand? Chapter 3. Mount St. Helens Ash. It began as a shocking flash on satellite feeds, a pale grey plume rising from Mount St. Helens, drifting high enough to be detected from orbit. For a moment, the Pacific Northwest held its breath. Was this the start of another eruption? Was the most infamous volcano in American history awakening once again? The imagery looked unmistakable, an ash column blooming above a mountain known for destruction. But what satellites captured wasn't magma breaking through the surface. It was something stranger, quieter, and just as unsettling. Mount St. Helens is a landscape carved by violence. When the volcano exploded on May 18, 1980, the blast obliterated forests, reconfigured entire river systems, and buried the land beneath billions of tons of ash, pumice, and volcanic debris. Those deposits still blanket the region today, thick layers of powdery grey material resting on exposed slopes, gullies, and barren plains. They are scars of an eruption that reshaped American geology. And on September 16, 2025, those scars came back to life. Powerful winds swept across the volcano's north flank at just the right angle and speed. The winds scoured exposed ash beds, lifting decades-old volcanic dust into the air. As the gusts intensified, the swirling ash column grew larger, denser, and more defined. To anyone watching through NASA's MODIS or Landsat imagery, it resembled the opening moments of a true eruption, an ash plume rising from the crater region. The visual was so convincing that emergency managers were immediately alerted, and aviation forecasters began assessing potential hazards. But within hours, USGS scientists confirmed the truth. This was not an eruption, it was a remobilization of ancient ash. Remobilized ash may sound harmless, but its implications run deep. It demonstrates just how unstable, fragile, and exposed the post-eruption deposits remain. The pumice plains around Mount St. Helens are covered with fine volcanic sediment that can be reactivated by drought, landslides, quakes, or powerful storms. Under the right conditions, the ghosts of 1980 rise again, drifting across valleys, rivers, roads, and nearby communities. This event also reveals something critical about volcanic landscapes. They are dynamic long after the lava cools. Even without magma movement, the volcano can disrupt air quality, visibility, water systems, wildlife recovery zones, and regional aviation routes. Every gust of wind becomes a reminder that the mountain's past still shapes the present. USGS quickly reassured the public that the volcano alert level remained at normal, and the aviation color code at green. There were no signs of magma ascent, no deformation, no tremor, no elevated gas emissions. Yet the ash plume taught a sobering lesson. The The surface of Mount St. Helens is unstable enough that even a strong breeze can mimic an eruption. So the bigger question looms. If mere wind can summon the remnants of 1980 into the sky, what might happen when real seismic unrest returns and the mountain begins to stir for real once more?
Chapter 4. Mount St. Helens Magma.
Perhaps one of the most intriguing ongoing research topics in volcanology concerns the possible connections beneath the Cascade volcanoes. Satellite monitoring and geophysical studies seek to understand whether there are significant pathways or zones of weakness in the deep crust where magmatic activity is shared or interacts among volcanoes like Mount Rainier, Mount St. Helens, and Mount Hood. While scientific debate continues about the connectivity of these magmatic systems, no confirmed discovery has established direct magma tunnels linking the volcanoes. The existence of such tunnels remains a subject of study, with most evidence supporting the idea that Cascade volcanoes generally have their own separate magma chambers and plumbing systems. Still, satellite data and subsurface imaging occasionally reveal geophysical anomalies, such as zones of partial melt or deep fractures, which can fuel scientific speculation about possible regional connections. If such deep pathways exist, they would redefine how we understand volcanic hazards in the Cascades, raising the possibility that activity at one volcano could influence others. However, at present, there is no confirmed evidence that an eruption or increased activity at Mount Rainier, for example, would directly trigger unrest at Mount St. Helens, Mount Hood, or vice versa. For now, the USGS and other researchers urge caution in interpreting these subtle signals, emphasizing that much of what is seen in remote sensing may be ancient, dormant features or inherent ambiguities in the underlying geology. Still, the allure and mystery of possible hidden connections inspires ongoing investigation. As each study refines our knowledge, the fundamental conclusion persists. Each volcano is unique and must be monitored individually, even as science continues to seek a broader understanding of their potential interactions.
Chapter 5.
Mount St. Helens Prediction. From the earliest days of volcanology, predicting eruptions has demanded a blend of art, science, and intuition. Researchers measure tremors, monitor ground deformation, and sample volcanic gases. But volcanoes remain among the most unpredictable natural hazards on Earth. Each rumble, sigh, and small quake could mean little, or it could mean everything. Mount St. Helens is among the most closely watched volcanoes in North America. Its sensor network picks up the tiniest vibrations and the smallest whispers from deep within. In recent weeks, these instruments recorded small earthquakes beneath Mount St. Helens and at neighbouring giants like Mount Rainier, Mount Hood, and Newbury. Each quake, each subtle shift, is studied in detail, analysed by teams from Seattle to Portland. But the challenge of prediction remains. Earthquakes occur routinely beneath the volcanoes of the Cascades, part of their normal behaviour. In 1980, Mount St. Helens gave clear, escalating warning signs for months, culminating in disaster. But in other years, seismic unrest has faded without incident. Satellites have become crucial tools, detecting ground deformation and heat that may indicate rising magma. Still, not all changes in the data mean an eruption is imminent. Current advisories stress there is no immediate eruption threat. The volcano alert level and aviation color code remain unchanged. USGS experts work round the clock, parsing data in real time and ready to escalate warnings if new signs of unrest appear. The science is advancing rapidly, but uncertainty is inescapable when it comes to volcanic prediction. The technology offers earlier warnings and better context, but the inherent unpredictability of Earth's inner workings remains.
Chapter 6. Mount St. Helens Community. For communities in southern Washington and northern Oregon,
Mount St. Helens is more than a distant scientific curiosity. It is memory, etched in loss, survival, and resilience. The spectre of the volcano is a shared chapter in local history, a test of preparedness, and a source of reflection each spring as new snow melts on its slopes. In spring 2025, marking the 45th anniversary of the 1980 catastrophe, Oregon declared May 18th to 25th Volcano Awareness Week. It is a time to honor those lost and remember the hard lessons earned through tragedy. Scars from the past are as much cultural as physical. Emergency plans are updated, schools teach the science and history of 1980, and officials run drills to practice evacuation for the day the mountain stirs again. But living near Mount St. Helens is also a story of renewal. Forests have regrown. Spirit Lake, once devastated, is now a thriving body of water amid wildflowers and wildlife. Communities have rebuilt and found pride in their resilience. The volcano attracts recreationists, artists, and scientists, all drawn by the wonder and challenge of a landscape shaped by fire. Each spring soon brings a riot of color on slopes once blasted barren, living proof of recovery. Still, the question echoes: what happens when the next eruption comes? Advances in monitoring provide more and better data, strengthening preparedness. Yet history reminds us that change can come suddenly. The story of this region is one of balancing risk and reward, vigilance and hope, always aware of the land's restless legacy. Chapter 7: Mount St. Helens Warnings. The recent episode of wind resuspended ash at Mount St. Helens, which led to widespread concern until clarified by the USGS, highlights the thin boundary between vigilance and alarm. This time, nature offered a false warning. Not lava, but wind lifting the ghosts of 1980 skyward. Officials stressed this was not a sign of renewed volcanic activity, keeping alert levels unchanged. Events like this force communities and scientists alike to ask uneasy questions. How much can be predicted? Can satellites and sensors always provide clear warnings? Or will the next eruption, like that of 1980, catch the world off guard despite our best efforts? Living with volcanoes means living with uncertainty. The lines between true warning and false alarm will always be blurry. No amount of science can remove all doubt. For geologists and emergency managers, such moments are tests, not only of technology and protocols, but of public trust. For residents and outdoor explorers, they are reminders that dramatic beauty comes with inherent risks, and that adaptation is a lifelong process. Chapter 8: Mount St. Helens Future. Mount St. Helens stands at the intersection of science, memory, and ongoing change. 45 years after the cataclysmic 1980 eruption, the mountain is a symbol of both destruction and renewal. Scientists affirm that Mount St. Helens has a high probability of renewed eruptive activity and is likely to repeat past activity, though when and how remains impossible to predict with certainty. Will destruction come, as in 1980, in the form of a lateral blast? Or could a smaller lava dome quietly rise within the crater, as has happened in recent decades? Large debris avalanches and major lateral blasts are considered possible, but not necessarily looming. The volcano remains closely monitored. Every tremor and anomaly is recorded, analyzed, and shared with the public. For those who live, work, and dream beside its shadow, Mount St. Helens is a reminder of nature's power, a teacher of humility and resilience. Each year brings both apprehension and promise, as wildflowers reclaim barren slopes and the new landscape takes shape. Beauty and risk are inextricably entwined. The volcano's story is unfinished. As research continues and monitoring improves, scientists expect new discoveries, some surprising, some reassuring, many subtle and open to debate. The future remains unwritten, and only Mount St. Helens will determine its next chapter. Could the next eruption be decades away, or only a matter of days? Does the mountain sleep, or is it always awake, its heart beating quietly far below? And as the world looks on, drawn to the drama and mystery of Mount St. Helens, one truth stands unchallenged. The mountain will shape its own destiny in its own time. What draws you to the story of Mount St. Helens? Is it the memory of destruction, the resilience of life, or the endless, restless mystery of the Earth itself? Let us know what fascinates you most in the comments below. Stay tuned as we continue to explore Earth's greatest forces and the stories they leave behind. And don't forget to subscribe and enable notifications so you'll never miss the latest discovery or the next warning from the restless giants that stand among us.